In this video, we're talking about solving for the point of intersection of two lines. We're still working with linear equations with two variables, but now instead of focusing on a single linear equation and trying to plot it or look for slope, now we're looking at what happens when we have two linear equations plotted together. In many situations, we end up with something that looks like this. So we've got two linear equations, an equation for line 1, an equation for line 2, and if we would graph them, what we would see is a point here where the lines intersect. This is called the point of intersection. And in this video, it's all about looking for the y and x coordinates of this point of intersection. There are three different scenarios that we can have when talking about point of intersection. The first scenario is the one we saw in the last slide, where we've got two lines that intersect and we solve for the point of intersection. But we may also have a situation where our two lines happen to be parallel. If our lines are parallel, then solving for point of intersection will end up giving us an error of some sort because parallel lines never intersect. The third scenario we could have is one where we say that the lines are coincident. Coincident means that we have a line and our second line actually lies exactly on top of our first line. And when we try to solve for point of intersection of these lines, we'll also get an error of sorts because instead of having one point where the two lines intersect, they actually intersect at every point. They have infinitely many points of intersection, or in other words, they are the same line. Let's go through a few examples. In our first example, we have two lines, x plus 2y equals 4 and 2x minus y equals minus 2. Let's say I want to solve for the point of intersection of these two lines. I'm going to show you two techniques. The first is called substitution. In substitution, what we do is we solve for one of the variables in one of the lines, and we substitute that into the other line to solve. So it looks something like this. Let's start with this equation here. I see that x doesn't have a coefficient, it's all alone, so I'm going to go ahead and solve for x in that line. So just moving everything over to the other side so that positive 2y becomes a negative 2y. Once I have this, one of the two variables isolated, so x isolated in this case, I'm going to take what x is equal to and I'm going to plug it into x in the other line. So the other line now looks like this. 2 times x, only instead of x, I use what x was equal to from the first line. So 4 minus 2y replaces x. And then the rest of the line, minus y equals negative 2. And now you'll notice that we went from a linear equation in two variables to a linear equation with just the variable y, which we can now solve using our techniques from section 1. So let's multiply through the brackets. We'll have 8 minus 4y, then minus another y equals negative 2. Grouping like terms, we've got our minus 4y and our minus y on the left side. We'll have minus 2, and then our 8 will become a minus 8 on the right side. From here, we can combine. Negative 4y minus y makes minus 5y equals minus 10. And dividing both sides by minus 5, we end up with y equals, the negatives cancel, 10 over 5 is 2. So the y coordinate of our point of intersection is 2. Now what we need to do is substitute that 2, let me arrange these nicely, substitute that y equals 2 back into either one of our first two equations. Either one of those top two equations will work. So let's use this form this equation right here. That was just our first line rearranged a little bit. So I take y equals 2 and I plug it back into that equation. So let's rewrite that equation so we have it here. It was x equals, let me remind myself what it was here, 4 minus 2y. X equals 4 minus 2y. So we've got what y equals, so we'll plug it in there. X equals 4 minus 2y, and our y is 2. So x equals 4 minus 4, which is 0. So our point of intersection for these two lines is x is 0, y is 2. If we were to graph the two lines, what we would find is that this is the spot where they would intersect each other. Let's look at the next example. X minus 3y equals 5, 2x minus 6y equals 1. For this example, let's use a different method. Last slide we used substitution. This time I'll show you how to use elimination. For elimination, what we do is we write the two equations on top of each other. And we want to make sure that as we do this, we've got the equations arranged so that the variables line up. So in other words, if I had this written as 2x equals 6y plus 1, I would have moved the 6y over to the left side so that it looks like the same format as the first equation. So I want them both to line up nicely. X's over x's, y's over y's, constants over constants, equals over equals, when I write them this way. Then I look at the variables and I want to match them up. So let's work with our x's here. Our first equation has a 1 in front of the x. The second has a 2 in front of the x. I want them to both have the same thing in front of x. So I'm going to multiply that x by 2. Only if I do that to that piece of the equation, I have to do it to every piece of that equation. So now we're looking at 2x minus 2 times 3 is 6y equals 2 times 5 is 10 over 2x minus 6y equals 1. Once I have my constants, my coefficients matched up in front of one of the variables, x, then I'm ready for the next step. The next step here is subtraction. So I'm going to subtract everything in the second from everything in the first. So 2x minus 2x leaves me with 0x. Minus 6y minus 6y, that's minus 6y plus 6y. That leaves me with 0y equals 10 minus 1 is 9. And what's happened here is that both of the variables eliminated. In most cases, what'll happen when we do this subtraction is the variable we've matched up will turn to 0, but the other variable won't, and then we'll be able to solve for it in that next step. Here, both variables actually ended up with a 0 in front, so now we're looking at an equation that says 0x plus 0y, or in other words, 0, equals 9. This is an error. 0 does not equal 9. So here's where we have the scenario where both of those lines are actually parallel. If I wrote them out in y equals mx plus b form, just rearrange them, what I would notice is that their m's would be exactly the same. If I had noticed that right up from the start, so looking at these two lines, if I had noticed that if I rearrange this one into y equals 1 over 3x minus 5 over 3. So I moved the x over and then I divided everything by minus 3. And if I rearrange the second one into y equals 1/3 x minus 1 over 6, again just moving everything over and dividing by the minus 6 that was in front of the y, they both have the exact same slope. So they were parallel. So if I'd noticed that from the start, I wouldn't have had to do any of the work below. I could have just said they were parallel. Let's look at one more example. 3x minus y equals 1, and 2y equals 6x minus 2. Let's try elimination again. So let's line them up on top of each other. Notice that as they are now, they're not quite in the right format. I'm going to need to move this 6x over to the other side. So 3x minus y equals 1. And then moving the x term over, I'll have minus 6x plus 2y equals minus 2. Now I want to match up. So let's match up our x's again. I'm going to have to take that first line and multiply every term by negative 2 so that we have minus 6x plus 2y equals minus 2. And our second line, minus x plus 2y equals minus 2. You should probably see here that those two lines are exactly the same. If I try to do my subtraction step, I'm going to get 0x plus 0y equals 0. Or in other words, 0 equals 0. That sort of is an error, but in another way. Instead of getting something like 0 equals 9, that's always false, now we have something that's always true. And that means that every point is a point of intersection, every point on that line. And these two lines are exactly the same. And once I did that matching up, I could see that both lines were indeed exactly the same. Looking up at the lines here, again, sometimes I can do something like multiply every term by 2 here and do a little rearrange and notice that both two lines are the same. And if I notice that right away, I can save myself all of the work. So these two lines were what we call coincident. So when solving for point of intersection of two lines, we have two methods, substitution or elimination. If we use either method, what we do is solve for one of the variables first, then plug that into either equation to solve for the remaining variable to get our point of intersection, xy. Or if we come across one of two types of errors along the way, if our error is false, then we end up with parallel lines, or that's what we had to start with. And if our error is something that's always true, then we started with lines that were the same, coincident. I hope that you understand solving for point of intersection. I'll see you in the next video.